Hello students, welcome to today's lecture on theory of machines. This is the part 3 of the lecture on analysis of block breaks. In previous two lectures we have discussed about the pressure distribution in both the cases of angle of contact, that is less than 60 degree as shown here and greater than 60 degree as shown here. And we also saw the equation of equivalent coefficient of friction as this. We then discussed about the forces acting on both the drum and the lever block assembly. We also learned to draw the free body diagram of the drum and the lever block assembly as shown here. Then in the analysis, we have discussed the two configurations of single block brake. First, when the fulcrum point is passing through the line of action of the friction force as shown in, and this was the equation for braking torque. And second, when the fulcrum point is above the line of action of the friction force, suppose by a distance b. So we discussed two cases, the clockwise rotation and the anti-clockwise rotation. So we got these equations. Further, in this case, we also learned about the self-locking brake and self-energizing brake. In today's lecture, we will discuss the third configuration of the single block brake, in which the fulcrum point will lie below the line of action of the friction force. So let's start with the third configuration of the single block brake. We will first see the clockwise rotation in this configuration and then discuss the anti-clockwise rotation case, and we'll further find out the condition of self-locking and self-energizing brake. So the configuration is something like this as shown here. As discussed in the previous videos, the forces acting on the block and drum will be like this as shown here. This is the radial force applied by the lever on the drum, and this is the normal reaction of the drum on the block. As the drum is rotating in the clockwise direction, so the velocity of the drum will be towards right. So the friction force on the drum will be towards left as shown here. So the friction force on the block will be towards right as shown here, as the friction force on the block will be in the direction opposite to the friction force on the drum. You can see here that the fulcrum point is below the line of action of the friction force by a distance b. So as we have discussed earlier, the braking torque is given by Tb is equal to mu into n into r. So we need to find out the value of n. So this we can do that by taking the moment about the fulcrum point. So taking the moment about point O, we have forces as n, f and p in the free body diagram of the lever. So moment of n about fulcrum point will be n into perpendicular distance of the line of action of the force n from the fulcrum point, that is nothing but a. So n into a will be the moment of force n, and this is in the anti-clockwise direction, so it will be a positive moment. Now force p will rotate the lever in the clockwise direction, so the moment will be negative. The moment of the force p will be given as p into the perpendicular distance of line of action of force p from the fulcrum point, that is nothing but this length L. So P into L will be the moment of P in the clockwise direction. Similarly, the force F, that is equal to mu n, will rotate the lever in the clockwise direction about the fulcrum point. So this will be a clockwise moment, so it will be a negative moment, and the magnitude will be mu n into the distance B. This is the perpendicular distance of the line of action of the force from the fulcrum point. So writing the moment equation, it will be n into A will be equal to P into L plus mu n into B. This is the anti-clockwise moment, these are the clockwise moment. So from here we can find out the value of n as follows. This term will be taken on the left hand side, so this will give us n into A minus mu B is equal to PL. So from here we get the value of n as PL upon A minus mu B. Putting this value in the torque equation, we get the braking torque as Tb is equal to mu PL R upon A minus mu B. Also from this equation we can get the value of P, the applied force P, as n into A minus mu B upon L. So this is the case when the drum is rotating in the clockwise direction. So we will see the case. So we will now see the case when the drum will be rotating in the anti-clockwise direction and the fulcrum point will be below the line of action of the friction force. So the configuration is something like this. This is the drum which is rotating in the anti-clockwise direction. This is the lever and the block. This is the force P. This is the radial force applied by the lever on the drum. This is the normal reaction of the drum on the block. The direction of the rotation of the drum is in the anti-clockwise direction. That is, the velocity of the drum will be in the left direction. So the friction force will act towards the right. This is the direction of the friction force on the drum as shown here. So the friction force on the block will be towards left direction, as the friction force on the block will be opposite to the direction of the friction force on the drum. So these are the forces, and you can see the fulcrum point is below the line of action of the friction force. So the forces are N, F and P. So we'll consider the free body diagram of the lever and take moments about the fulcrum point to get the value of N. So taking moments about O, we have N into distance A is in the anti-clockwise direction, then F into distance B also in the anti-clockwise direction, and this will be equal to P into this distance L in the clockwise direction. So this is the moment equation, N into A plus mu N into B. These two are the anti-clockwise moments, and is equal to P into L. This is the clockwise moment. So we will take N common from here. So this will give us N into A plus mu B is equal to PL. So we will get the value of N as PL upon A plus mu B. Again, putting this value of N in torque equation, we get the value of torque as TB is equal to mu PL R upon A plus mu B. So again, we can get the value of applied force in this case from this equation. P is equal to N A plus mu B upon L. So these are the equations for the configuration when the fulcrum point is below the line of action of the friction force for clockwise rotation and for anti-clockwise rotation. We can observe this thing that these equations we have already seen earlier. Where have we seen these equations earlier? Let's see. These are equations similar to the equation that we have just derived for the case when the fulcrum point is above the line of action of the friction force. Only difference is the direction of rotation of the drum. In this case, we got the positive term for clockwise rotation and negative term for anti-clockwise rotation. Whereas in this configuration, when the fulcrum point is below the line of action of the friction force, we got negative term in case of clockwise rotation and positive term in case of anti-clockwise rotation. So these are just opposite. Well, having derived all these equations, let's see the condition of self-locking brake. So we have seen earlier for this configuration and anti-clockwise rotation case, we got this as the equation of force applied, and similar equation we got for this configuration in clockwise rotation. So we have in this equation, if A minus mu B is less than or equal to 0, then the applied force will be virtually 0 and the brake will lock by its own. So this will be self-locking brake. We have already discussed this earlier. So what will be the condition of self-locking brake? The condition of self-locking brake is B should be greater than or equal to A by mu. So this is the condition of self-locking brake. Having seen that and having derived all these equations and discussed about the self-locking and self-energizing brake, and similarly the same equation which we got for this configuration we have obtained for this configuration also. You can see this. We have obtained the same equation here for this configuration. And you can see that the direction of moment of the friction force is same as the direction of moment of the applied force. So we can say that the friction force aids in applying the brake. So this is the condition for self-energizing brake. So these are the two configurations in which we will get the self-locking brake and self-energizing brake. For the configuration when the fulcrum point is above the line of action of the friction force, if the drum is rotating in the anti-clockwise direction, then we will have a self-energizing brake. And for the configuration when the fulcrum point is below the line of action of the friction force, if the drum is rotating in the clockwise direction, then we will have self-energizing brake. So having seen all this and derived the equations, we should now proceed for numerical problems. So the first problem that we'll take up is as follows. The brake drum of single block brake is rotating at 500 rpm in the clockwise direction. The diameter of the drum is 400 mm and the single block brake is of the type as shown in figure. This is the figure. The force required at the end of the lever to apply the brake is 300 Newton. If the angle of contact is 30 degree and L is equal to 1 meter, A is equal to 300 mm, B is equal to 25 millimeter, then determine the braking torque. The coefficient of friction is equal to 0.3. So this is the configuration diagram given, and let's proceed with the solution. So first we should write what is given. So we are given the diameter of the drum as 0.4 meter. So the radius will be 0.2 meter. The force P applied on the lever is 300 Newton. The angle of contact is given less than 60 degree, that is 30 degree. The length L, that is the length of the lever or the distance of the fulcrum point from the point where the force is applied on the lever, is 1 meter. A is 300 millimeter, that is the distance of the central point of the block to the fulcrum point is 0.3 meters. And similarly B, that is the distance between the fulcrum point and the line of action of the friction force, is 0.025 meter. Friction coefficient is 0.3 and we have to find the braking torque TB. So let's see how to solve this problem. So this is the free body diagram that we have already learned previously. So we'll just use this to solve the problem. Now in the free body diagram of the lever, taking moments about the fulcrum point, we have the forces N, F and P in the free body diagram of the lever. So the moment equation will be N into A in the anti-clockwise direction plus F into B, this is again in the anti-clockwise direction, and will be equal to P into this distance L in the clockwise direction. So this is the moment equation, and we'll put the values of various parameters in this. N into A is 0.3 meter, mu is again 0.3, then B is 0.025 meter, the force P is 300 Newton and length of the lever is 1 meter. So from here we get the value of N as 975.6 Newtons. Now putting this value of N in the equation of torque, that is given as TB is equal to mu into N into R. We have TB is equal to mu is 0.3 and we have found out as 975.6 Newton and R is 0.2 meter. So the value of T obtained here is 58.536 Newton meter. So this is how you can find out. This is one of the method. We could have directly used the formula which we derived earlier. TB is equal to mu PL R upon A plus mu B. So directly we could use this formula, or you can take the moments and find out the value of TB. Let's see the next problem. So the problem 2 is, if the brake drum in the problem 1 rotates in the anti-clockwise direction as shown in figure and all other data remains the same, determine the braking torque and the value of B for self-locking of the brake. So this is the configuration and it is given that all the data are same, only the direction of rotation is changed to anti-clockwise direction. So in this case only the direction of force of friction will be changed. So let's see the solution. The given parameters are same. The diameter of the drum is 0.4 meter. The radius of the drum will be 0.2 meter. Force applied is same 300 Newton. Angle of contact is 30 degree, which is less than 60 degree. Length is 1 meter. A is 0.3 meter. B is 0.025 meter. And the coefficient of friction is 0.3. And we have to find out the braking torque and the value of B. So we see the free body diagram. It will be something like this. This we have already discussed. You can see that the direction of friction force has changed since it is in the anti-clockwise direction. So you can see the direction of force will be in the left direction. You can observe one thing, that the direction of the friction force on the block is always in the direction of rotation of the drum, right? So this is just a point to remember. This will make it easy for you to solve the problems. So let's proceed with the solution. So we have to find the braking torque, and for this configuration the braking torque is given by TB is equal to mu PL R upon A minus mu B. This equation we have already derived earlier as shown here for the anti-clockwise rotation in this configuration. This is the equation of TB. So directly putting the values of various given parameters in this equation, we have TB will be equal to mu is 0.3, force applied P is 300 Newton, length is 1 meter, then A is 0.3 meter, mu is 0.3 and B is 0.025, and similarly R is given as 0.2 meter. So from here we can directly get the value of TB as 61.538 Newton meter. So this is the other way by which we can solve the problem. Now you have to find the value of B for self-locking brake. So what is the condition of self-locking brake? This we have already discussed earlier, shown here. This was the condition of self-locking brake. B should be greater than A by mu. So let's apply this condition there. B is greater than or equal to A by mu. So put the values of A and mu. A is 0.3 and mu is also 0.3. So we get B should be greater than or equal to 1 meter for this brake to be self-locking brake. So this is how you solve these problems. I hope you have understood the concepts of block brakes and how to solve the problems on block brake. And I hope you will solve more problems like this from your textbook and also practice some of the gate problems. In case of any doubt, feel free to contact me. So this is all for today's lecture. In next lecture, we'll discuss the double block brake. Thank you.